Okay, this is from your lab 2.2, number 6. Find all real zeros of the polynomial function f of x is equal to x to the fifth minus 16x cubed plus 64x. So when finding zeros, we always want to factor. The simplest factor we can get out of this whole equation here is an x, okay? So x times x to the fourth minus 16x squared plus 64. And the next move is a little tricky here. So you can treat it like a quadratic if you write it like this: x squared squared minus 16 x squared parentheses plus 64. And when I write that, I want you to think, okay, what is x squared minus 16x plus 64? And I think we can all factor that pretty quickly. That would be x here, x here. Yes, it's a perfect square trinomial. So we'll just write that. And we can even go one more step and write it as a square. But that's the same thing here. Like if I just treat this whole thing as my x guy down here, and this whole thing as this, I can factor this guy in the same way. So let's take a look and see if we can see that. Okay, so that means I can write this as x, and let's see, some parentheses there, right? The 64 is the 8. That's not the hard part. The hard part is right here. So that's going to be x squared goes here, minus 8, and another x squared minus 8 goes there. And, like always, you should check your work, and you can see that x squared times x squared is x to the fourth. A minus 8x squared minus an 8x squared is a minus 16x squared. And negative 8 times negative 8 is a 64. So you can see that works if you can just see it as a quadratic. Okay, and then since we want to find all the zeros, we know that we have to set f of x equal to 0. So setting all these factors equal to 0, we're going to get x is equal to 0, or x squared minus 8 is equal to 0. And so x squared is equal to 8. And one more move, forgive me, I'm going to do it up here, is x is equal to plus or minus the square root of 8. And of course the perfect square in 8 is 4, comes out as a 2 root 2, but it looks like the answer is just written as this guy here, so we can stop right there, but we should be able to do that. Okay, so the answer here is A. Okay, no need to check for extraneous solutions. We're not dividing by x, or there's no square roots in our original function. So, okay, I hope that helps.